Hello everyone, I welcome you in this video lecture, and in this video lecture we will learn how to find inverse of a square matrix. Say this is the square matrix given to us and we have to find its inverse. Okay, so we'll learn how to find its inverse. So first of all, let us suppose that this matrix is equal to A. Assume it as equal to A. We have assumed it as a matrix A. So we need to find its inverse. So for that we know that A inverse is equal to adjoint of A divided by A determinant. So this is the formula of A inverse. So to determine A inverse we need to determine two things. First thing first is determinant. Second is we need to determine the adjoint. So we will separately determine these two things. Firstly the determinant, then the adjoint. And really believe me, this calculation of both these things is really very easy, and we will step by step move forward. Firstly we will try to find the determinant of A. So for determinant of A, write it in the vertical lines. I have already told you this is symbol for determinant. Write the elements of the matrix within the vertical line 1, 2, minus 2, like I have written the first row, minus 1, 3, 0, 0, minus 2, 1, and within the vertical lines. Fine. Now this determinant can be expanded along any of the row or column. So let us take the simpler one, because here it is 0. Look over here, one thing is 0, so that will help us. So we can expand it along column 1. Also we can also expand it along row number 1. So whichever way you want to expand it, we can expand it. So for the time being I am going to expand it along the column number 1, because here 1 0 will help us to find, and will help us to make this determinant calculation easier. So I am going to make use of this 0 which is given in the column number 1. So how I am going to make use of it? By expanding it along the column number 1. Fine. So what it will be? For that we need to write the signs also. For sign you can just mark the sign table, that sign matrix, plus, minus, plus, minus, plus, minus, plus, minus, and here is plus. So we are interested in this column number 1. So 1, leave first row and its column this. What we are left with? 3 0 minus 2 1 within the determinant sign, 3 0 minus 2 1, and within the vertical lines, and here sign is positive. Now next is minus 1. Right here the whole element as such, minus 1, leave its row and column, row number 2, column number 1. We are left with, look, this gone, this gone. We are left with 2 minus 2 minus 2 1 within the determinant sign, 2 minus 2, this gone, this, minus 2 1. Fine. And here sign will be minus. Fine. Next is 0. Here will be 0 multiplied by, and 0 multiplied by anything is 0. So we will also write, but it will be 0. This, leave this row, this column. It will be 2 minus 2, 3 0, and sign will be, here this element has sign positive, so this will be plus sign. So now next it will be Now you just go from up to down and down to up, and here also up to down and down to up. Fine. Here also up to down and down to up. Fine. So it will be 1, 3 into 1. When you go up to down, sign remains the same, so it will be 3. When you go up, sign becomes negative, but minus 2 multiplied 0 is 0, so this will be minus 0. Fine. Minus minus will be plus 1 into 2 into 1. When you go up to down, sign remains the same. 2 into 1 is 2. When you go down to up, sign will change. Minus 2 into minus 2 is 4, and 1 is a change of sign, so it will be minus 4. Now look, 0 multiplied by anything is 0, because this, after solving this one, we will get 6, and 6 multiplied 0 is 0, so this will be 0. So what we are left with, it will be 3 plus 2 minus 2, it will be minus 2, and it will be 3 minus 2, which is nothing but equal to 1. So determinant, you must, before calculating the adjoint inverse of A, you must make sure that this inverse is not equal to 0. 1 is of course not equal to 0. Therefore I can say that A determinant is equal to 1 is not equal to 0 implies A inverse exists. Fine. Now it guarantees that A inverse will exist. You have to make it sure that it is not 0. If it is 0, then A inverse will not exist. It will be singular matrix. Now see, we have calculated A determinant, and A determinant is non-zero, which is 1. So now we'll move further to find adjoint of A. For this we will find the cofactor matrices. Okay, for that we will calculate the cofactors. First we calculate, and this sign matrix will help us in the same way. So let me first calculate the cofactor matrix of A. This element is A11. A11 means first row, first column. So first row, first column intersection this point. This point is A, and its cofactor is named as capital A11. This is cofactor of A11, and here A11 is 1. Okay, this cofactor is equal to, and if you want to write the sign from the matrix here, you can take it as such, or otherwise here only sign will be taken. You have to remember that unlike the determinant, where we have also multiplied the elements with these determinants and also use the sign, but here only sign will be taken, no multiplication with the element will be done. Here, like if we will write the minor, this and this, leave this, so what it will be, 3 0 minus 2 1. Fine, leave its row and its column, it will be 3 0 minus 2 1. So now one way is that you just pick the sign from here, it will be plus, or you can use the formula minus 1. This 1 is present at the position 1 1. 1 1 represent first row and first column. So what you will do, you will raise these 1 plus 1 to the power of minus 1. So it will be minus 1. 1 plus 1 is minus 1 square, which is plus. And when you solve this, this will go down, this will go up. When you go down, it will remain the same 3. When you go up, it's 0 multiplied by anything is 0. So this thing is 3. or simply from here you can also write, if you don't want to write this thing, you can take it infer from the sign matrix that this is plus minor, so you can directly write a plus, and this is 3 0 minus 2 1 is equal to 3. So it is up to you that how you do it, but I would prefer that you will adopt the right way. Just we will mention that it is minus 1 raised to the power sum of subscript. Okay, now this is cofactor of the element a11, which is 1. Now we will find other cofactors, and for this I am going to rub from here. Everyone say rub it from here, or I can make some space, and we will write it here. Okay, for this I am going to write the matrix again, and matrix is 1 2 minus 2 minus 1 3 0 0 minus 2 1. Fine, this is the matrix. Now we'll calculate a one 2, which is cofactor of, write it again, cofactor of a12, and which is the element 2. Fine. So what it will be, again the same, it's subscript notation sum, 1 2 minus 1 raised to the power 1 plus 2. Now you have to put the sign only, don't multiply with the element 2, no, don't need to multiply it with, that is in case of determinant, now not here. So it will be, leave this row and this column, what we are left with, minus 1 0 0 1. Look, leave this and this, minus 1 0 0 1 0 1. Now what you'll do, you will multiply up to down, down to up, minus 1 cube, 1 plus 2 is 3. Okay, minus 1 into 1 is nothing but minus 1, and sign will remain the same. 0 into 0 is 0, and when you go from down to up, it's minus, so it will be minus 1 cube is minus, and into minus 1, which is nothing but 1. Now we'll calculate a13, and if you want to put the sign from the sign table, then you can also do it. It is plus minus plus minus plus plus minus minus plus. From here you can also pick the sign. Right, what is capital A13? Cofactor of element A13, which is minus 2. What it will be? It will be minus 1, or you can pick A13, this is the position of minus 2, sign is positive, or you can also write it from here, minus 1 raised to the power sum of subscript 1 plus 3. Now leave this row and this column, what we are left with? We are left with minus 1 3, we are left with 0 minus 2. So now minus 1 raised to the power 4, now this will go down and this will go up. Look, when you go down, sign will be positive, and you just multiply the element and write the result. Minus 1 multiplied by minus 2, you know, is 2, so you just write 2, and when you go up, you put the minus sign, but 0 into 3 is 0, so this will be minus 0. Minus 1 raised to the power 4, when minus is multiplied 4 times, you know result is 1. 1 into 2, this will be 2. Now next we will calculate this element. This is which element it is? It is second row, first column. So this is A21, which is cofactor of A21, which is equal to minus 1. So this will be minus 1 raised to the power sum of the subscript, that is 2 plus 1 Fine. Now leave this row and this column, the rows and the column of the element -1. This is second row and this is first column. So what we are left with? 2 minus 2, 2 minus 2 minus 2, 1. Now you just put this down, you just put this up. What it will be? 2 into 1, sign will remain the same. It will be -1 cube. 2 plus 1 is cube. Fine. 2 into 1 is 2 and sign will remain the positive. It will be 2. -2 into -2 is 4, and when you go up, sign will become -4. So it will be -1, and 2 minus 4 is -2. -1 into -2 is 2. Fine. Now we will calculate the next cofactor. This is a to 2, and write the meaning of this one. Cofactor of a to 2, which is equal to 0. Now you can write it as -1 sum of the subscript, leave this row and this column 1 minus 2, 0 1. So this will go down, this will go up. This will be -1 raised to the power 4. 1 into 1 is 1. 0 into -2 is 0. So -1 raised to the power 4 is 1, and which is 1 multiplied with 1 is 1. Now next cofactor is, you have to calculate the cofactor of each and every element, and so far we have calculated the cofactors of 5 elements. 4 are left, so we don't leave anything unturned. So now we'll be moving towards the next element, and which is this one, and its position is, simply second row third column, second row third column. So first is row, it is a 2 3. So next cofactor will be a 2 3, which is cofactor of a 2 3, and the element here is element here is 0. And look over here, here element instead of 0 it is 3, it is 3. Fine. So what will be the cofactor of a 2 3? Leave this row and this column 1 2 0 minus 2, and -1 raised to the power sum of subscript, that is 2 plus 3. Leave this and this 1 2 1 2, leave this and this 0 minus 2. What it will be? This will go down, this will go up. What it will be? -1 raised to the power 5 is -1. 1 into -2 is -2. 0 into 2 is 0, and this will become, I am writing minus because when you go up there is obviously minus sign. So 0 into 2 is 0. I could have also written plus 0 because -2 plus 0 is -2, but I am writing it as per the rule. When you go up, sign is negative, so I am writing it -2 minus 0. So -1 when multiplied with -2, it gives 2. Now we calculate the next thing, which is the cofactor for a 3 1. This element, this is equal to cofactor of a 3 1, which is element is 0. Now what it will be? -1 raised to the power sum of subscript, that is 3 plus 1. Now leave this row and this column. What we are left with? 2 minus 2, 3, 0. Now this will go down, this will go up. What it will be? Minus 1 raised to the power 4. Fine. And inside 2 into 0 is 0. When 3 multiplied with minus 2, it gives minus 6. But when you go down to up, there is additional minus, so minus 6 will become plus 6. So this will be minus 1 raised to the power 4 is 1, and into 6 is nothing but equal to 6. Now we will calculate A3, 2, which is cofactor of A3, 2, and the element is minus 2. This is nothing but equal to minus 1, 3 plus 2. Now leave this row and this column. What we are left with? 1 minus 2, leave this minus 1, 0, minus 1, 0. So this will be minus 1 raised to the power 5. What it will be? Minus 1. Now you mark the arrows up to down, down to up. 1 into 0 is 0. Minus 1 into minus 2 is 2. And when you go down to up, sign will change. So this will be minus 2. So this will be minus 1 into minus 2. This will be 2. Next we calculate the cofactor of last element, that is A33, which will be minus 1 raised to the power 3 plus 3, and inside determinant leave this row and this column. It will be 1, 2, minus 1, 3. Mark the arrows. Minus 1 raised to the power 6 into 1 into 3. This will be 3. Minus 1 into 2 is minus 2. And when you go down to up, sign will change. So this will be 2. And this is nothing. Minus 1 raised to the power 6 is 1. 3 plus 2 is 5. So this will be 5. Now we have calculated the cofactors for each and every element, that is 9 elements. So now we will form the cofactor matrix and take it transpose, which will be nothing but the adjoint of A. Okay, now we'll see form the cofactor matrix. So let me form the cofactor matrix. For that, here I am forming that and write it as adjoint of A is equal to A11. This position is A12, A13, A21, A22, A23, A31, A32, A33. So this is cofactor matrix, and take its transpose, which will be nothing but adjoint of A. Now write the element value of cofactor that we have calculated. What is the value of A11? 3, A12, 1, A13, 2, A21, 2, A22, 1, A23, 2, A31, 6, A32, 2, A33, 5, and take its transpose. What it will be? This will be further equal to 3, 1, 2. This will be in the vertical line. Transpose means now I am writing rows as column. I have told you the meaning of transpose. Rows as column. 2, 1, 2, 1 will be second column. 2, 1, 2, and third row will be third column. So this is nothing but adjoint of A. We have calculated adjoint of A, and we know that A inverse is equal to adjoint of A upon a determinant. Okay, and adjoint of A we have calculated. I am writing it here again. 3 2 6 1 1 2 2 2 5 and divided by the determinant of A is, we have calculated it is 1. So 1 by 1 is 1, and 1 multiplied with each and every element of the matrix will give the same matrix. So this will be nothing but 3 2 6 1 1 2 2 2 5 is the inverse of A. It is written as inverse of A. Okay, so that is what we were required to determine. So that's all I have from this lecture, and I hope that you will be able to understand, given the matrix A, how to find its inverse. Firstly, you check for a determinant and it should be non-zero. Then you find the cofactor matrix A11, A12, capital sign symbol denote its cofactor of the smaller element A11, and take its transpose. This will be the adjoint of A. Then you will divide adjoint of A with a determinant and will get the inverse of A. So if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye. Take care, bye bye, and see you soon. Thank you very much.